Hi everyone, I'm Dapper Dan, and welcome to this Smart Contract Development Roadmap course. So this course is designed for anyone who is interested in becoming a smart contract developer or just want to understand really how smart contracts work. In this session, we'll talk about what is a smart contract. Before we begin, I would like to point you to a Web3 Fundamentals course. So if this is your first time hearing about smart contracts, I would recommend you actually visit that course. It gives you a bit of a better understanding of the Web3 world in general and how smart contracts, just a bit of very important piece, fits into place when we talk about Web3 development. So there's the URL, and feel free to stop this video and go to that. I'm assuming if you're still here, you've done the course, or you have at least a good understanding of Web3 and what that entails, and want to dive deeper into smart contract development. So what this course will cover, or this roadmap. First, we'll answer what is a smart contract. Coincidentally, I also have a session of that in the Web3 Fundamentals course, but this will give you more deeper dive of the actual parts and concepts of smart contracts. Then we'll look at developer tools. How can one make and write a smart contract, deploy it, test it, and all the environment, setting up your environment to actually do and write smart contracts or programs. Then we'll look at this fundamentals of Solidity. So this course will be focusing on Ethereum development and particularly the language of Solidity. So that's where we'll look at the fundamentals of that language. Then we'll look at security and auditing. Smart contracts, as we will discuss later, are a very important part of the Web3 development side because the code is immutable. So we'll look at actually how to make our smart contracts secure and audit them to make sure that they are working properly. And then we'll do some testing. Testing is always important in any sort of software development, but even more important in smart contract development. And then lastly is deployment. So actually getting your smart contract first possibly to a test net to see how that would function, and ultimately to mainnet, well, we'll want to actually have users use our smart contract or even another smart contract communicate with it. So let's just do a quick overview of smart contracts. So the simplest definition is that they're self-executing programs. So they don't need to have someone to push the start button. Essentially, they after they're written and deployed, they can be run by certain events or certain conditions that are built into that contract. Again, the programming language that we will talk about in this roadmap or this course is Solidity. Other blockchains, maybe let's say Solana, use other languages like Rust for smart contract development. So if you're interested in those that blockchain, I would point you to other elements of Rust and how to develop there. They are also stored on a blockchain. So we were talking about in the Web3 fundamentals course, but you know that each block has data, and in that block of data, not only will we having transaction data, but we could actually have the code of the smart contract. We're again focusing on Ethereum here. Ethereum virtual machine is where it actually does the execution of the code. And we'll talk about how smart contracts communicate with the EVM for short. And then lastly, external communication. So these smart contracts, they live on the blockchain, and they're not just like a server where you can give a direct call to. We have data within the blockchain that the smart contract uses, but in certain cases, we would actually want the smart contract to take some external data. Again, some sort of maybe some service or data that may be important to how the smart contract is executed. And for this, we actually need to use a special concept or special service called oracles. Again, since we're dealing with immutable data, it's important that also that these oracles present us accurate and ensure that the data is also not being tampered with. So let's look at the three main concepts of smart contracts. And I've already said one, which is that they are immutable, they're composable, and that they're distributed. So immutable, what does that really mean? Well, the code can't be changed. And I think if you come from any traditional software development, you're probably used to maybe using tools like Git, where you've probably made a mistake, you've deployed to, let's say, production, you want to change the code, you can just go in, make a pull request and update the code and push it out back to production. That's not the same as when you're working with smart contracts. Once you deploy this into the test net or main net, the code actually lives in the block. And again, since all the security of a block is that if they were making any tampering, that all the other future blocks would be invalid. You cannot necessarily change the code of the once it's committed to a block. And that might sound scary, but it's actually a good point to understand what some of the benefits of that. And I think primarily the one is building trust. So in traditional contracts, we typically work with a third party on making sure that the contract is executed and executed the way that we expect it to, right? So if you want to lease a home or loan a home, for instance, you would need to work with the bank, and the bank needs to then execute that contract with the owner of that house in regards to that you know get the house, it's in a certain condition, and also that all of the finances get transferred into each other's bank accounts. In the case of smart contracts, we don't need a third party. But again, the way to build the trust is that this code always operates and expects the same sort of outputs and inputs when we give it the right amount of metrics. So in that case, it's also building a level of trust that we haven't seen before in regards to transacting with each other. And with that, it's super important that security, that the smart contract is secure, and that it's audited for any loopholes or vulnerabilities. Because again, once you deploy your smart contract to a network, then anyone can publicly see that code and see if there's any vulnerabilities there. And worst case scenario, which could be really bad, is that your wallet or any sort of associated accounts to that smart contract get drained because of those vulnerabilities. And that's probably what you'll see a lot of in the news as far as if Web3 is going to make it, is all of these big time stories of hackers going in and finding vulnerabilities in the code so that they can transfer funds that are unnecessarily intended for with the intent of the smart contract. So it's super important that you don't make the news and you make sure that your smart contracts are secure and that they're audited. There's external services that we'll talk about in that particular section of this course, so you can get a better understanding of what we mean by that. Next is the composable. And what that means is that these smart contracts can actually call one another. And what's really nice about that is that you can make a smart contract that addresses a specific use case and does one thing really, really well. And doesn't have to, like when you're working with other certain software, try to pull in different functions and different things that and operate in different ways that maybe it's not doing as well at. So with that, we get this idea that contracts are sort of Legos. So in the case that you can use a smart contract that maybe performs a transfer or a token exchange, and within your application, your decentralized application, you can call that smart contract. Or if you have a smart contract that also works with that, let's say a DAO smart contract that is needing to do a coin exchange, you could incorporate or call the smart contract that does that exchange really well. Let's say a Uniswap smart contract, and that really saves development time because again, now you don't have to write code from square one. You can use someone else's publicly verified code that's already on and deployed on the main network, and then you can now use your contract to call that and you perform the function specifically to what you're interested in, and making sure, again, saving the dev time and making sure you're doing what the one thing that you're focusing on really well, and that relying on the smart contract that's been audited and used before, so you can perform and work with some sort of rest peace of mind that your application, your smart contract will work. And lastly, it's really community focused. So anyone can view the code of a smart contract. It's by design that these are open source. And again, if you find that this is necessary for your smart contract or it's performing some operations that are of interest, you can freely associate your smart contract with that and make a call to that. You don't need to authenticate yourself in regards to another service or make an account somewhere. Again, it's completely open source, and you can even use that code and improve on that code later on by deploying another smart contract that maybe performs something better. And then lastly, it's distributed. So we already talked about the Ethereum virtual machine, the being sort of the world computer and being able to perform operations on within these sort of nodes. And that will be really important when we talk about deployment later on of how you actually deploy your smart contracts. But in the ideal world, you will have less or zero downtime with that, because again, no node can kind of single-handedly bring down the entire network. While some blockchains have experienced downtime, maybe in a less decentralized manner, this is the ultimate goal of a blockchain or even a network, is that there is less downtime. And again, since your contract is deployed to that network, you will also experience this less or zero downtime in regard to calling your smart contract and executing those functions, which you might not necessarily experience if you are hosting that on maybe a server somewhere, where you might have more downtime to experience. You'll also know that the transactions are validated. Again, since this is on a blockchain and each node needs to accept by consensus via the protocol that's tied to that blockchain, that these transactions are validated, they're operational, and they are not providing anything in regards to someone trying to, let's say, drain a wallet single-handedly. That each of these transactions again are on the network and approved by the nodes that participate in that network. And it's all transparent. So you can use things like Etherscan, which we'll probably discuss later on in this course, to see transactions with the contract and all the calls that are being made there. And you can even understand if you, let's say, did deploy a smart contract and it was attacked, exactly how that attack is working, and because you can see all the transactions there. So it gives you a better understanding of how smart contracts function. And I do encourage anyone to go in and just look at a smart contract, look at the recent transactions, and see again how in the real world smart contracts function and their benefits there. And lastly, again, since it's distributed and every node needs to compute on this, there actually is a cost associated with executing that. And specifically with the Ethereum virtual network, virtual machine, you're really focusing on gas cost. So each operation that you program within a smart contract has an associated gas cost with it, and also fluctuates in regards to the network traffic, whether you're operating on a busy network at that time or a less busy network. And we'll go way into more details later in this course, how gas functions and how to sort of compute that within your smart contract. So let's look at the elements of a smart contract. So there's data, there's functions in the smart contract, and there's events. So on the data side, there's two types of data. One is storage and the other is memory. Storage is permanent data, so anything that is going to be tied to the smart contract and actually stored on the network. So this is particularly the data types like you're probably most used to if you come from another programming language, like booleans, integers, strings. We do have a native data type towards smart contracts, or in Solidity, called the address, because each smart contract or each wallet has an address there, so it makes it easy to pull from. And these are all sort of declared by the programmer or developer of the smart contract. Next is memory. So memory is actually just based on the function execution. So its lifetime only lasts until the function is executed, and once done, it is cleared. It actually stores the function of the argument. So if you're making a function and declaring an argument within there, it is actually committed to memory, and also again declared, much like storage, by the developer. On the function side of things, so there's two types of functions. There's an internal and external functions. So internal functions is only something that's called by the contract itself, or if you have any connected or inherited contracts, that smart contract could also call those functions. While external is something that is specifically called by other contracts outside of that contract. So if you're interested in working with, let's say, a Uniswap or let's say Aave flash loan contract, you would use its external functions to execute that. Within the internal and external functions, we have a public and a private type functions. So public functions can be called internally as well as externally, much like the internal functions, where if you want to make a private function, only the current contract, so only the contract that function exists in can make that call to the function. Next is events. So smart contract events. So anytime something actually happens of importance, events are emitted, so basically publicly broadcasted. So let's say, for example, transfers. So anytime someone contacts or calls a contract to transfer some funds to another account or to, let's say, a lending pool, those events are emitted, and that's a transfer event. They can also be listened to, which is really where the value is. So if you had a front end that wanted to, let's say, communicate to the user every time a transfer event happened on a certain contract, you would listen to the transfer event of that contract that's being emitted, and then you could display that information onto the front end. And it's also developer defined. So using the word emit as keyword next to a function, make sure that that function or that event, it will be emitted once executed. So that's it for the smart contract fundamentals. Now you would go further into actually how and finding the right tools for development, deploying those contracts, testing, and auditing. So I wish you good luck on your smart contract journey.